Okay, so we can start. Hello, everyone. Good morning. Good afternoon. Good evening to everyone wherever they are attending this webinar. I am Ali Rahman, hosting Pavement webinar series, an initiative which has just recently launched at Southwest Jiaotong University, aimed at enriching our academic environment by inviting distinguished and international scholars, researchers, and experts across various domains of pavement engineering and materials to share their insights and expertise as a speaker in this webinar series. In fact, the core objective of this initiative is to expose our students, researchers, and faculty alike to the forefront of research and the latest advancement in pavement materials and structure through this pavement webinar series. And today, we have the eighth episode of this webinar series, and the title of today presentation is Advances in Bio-Based Asphalt Additives, Steps Toward a Low Carbon Asphalt Future. And our today speaker is Dr. Hassan Tabatabaee from Cargill Bioindustrial. Dr. Hassan Tabatabaee is the global R&D leader for asphalt solutions, power systems, and VACs at Cargill. Over 10 years with Cargill, Hassan led and contributed to the development of novel biorenewable additives for enhancement of bitumen, infrastructure materials, and industrial chemicals, most notably the ANOVA asphalt additives product line consisting of rheology modifiers, recycling agents, emulsifiers, and processing additives for pavement, roofing, and infrastructure preservation markets. He holds a PhD degree from the Department of Civil and Environmental Engineering at the University of Wisconsin-Madison, with a major in engineering mechanics, with a minor in engineering mechanics from Department of Material Science. He's received his both master and bachelor's degree from Sharif University of Technology in Iran. Hassan, seven patents and over 30 peer-reviewed publications over the past 15 years have focused on biorenewable infrastructure chemicals, pavement materials, and bitumen chemistry. Dr. Tabatabaee has led and contributed to various industry and specification committees and served as a principal investigator and co-PI on nationally funded research projects on various infrastructure technology. He has worked on implementation, education, and specification for sustainable infrastructure technologies in partnership with industry and academia in over 20 countries, over four continents. So thank you so much, Hassan, for accepting my invitation. It's a privilege to have you in this webinar series. And before starting the presentation for our audience, I would want to mention that the speech after this webinar will be started first by the presentation and a speech by Dr. Tabatabaee, and then it will follow by a Q&A session. So whether during the presentation you can type your question in chat box, and after presentation I will read the question, and hopefully Dr. Tabatabaee will answer us, or you can after presentation raise your hand, turn on your mic, and ask your question directly from Dr. Tabatabaee. With that, I give the floor to Dr. Tabatabaee. Hassan, thank you so much. It's back.
Thank you very much, Ali, and thank you to you and all of our hosts for having me. Definitely, it's a privilege to be able to be here with you today, and it's my pleasure to talk to you a little bit about bio-based technologies and how they fit into our pavement industry. I will share my screen.
Mhm. Yes, yes, we can see
Hopefully
your
you
screen.
see it
Yes,
now. Perfect.
yes, yes, great.
Excellent. So as you had said, my topic is advancement in bio-based additives, steps toward a low carbon asphalt future. First off, I just a brief introduction of Cargill. This is it's an international company based out of Minneapolis in the U.S. As you can see, the company is actually most well known for food and agricultural and commodities. I'm part of the bioindustrial part of this business, which is focused on bio-based industrial chemicals. The locations you see on the map here are only for the industrial business, and it's company's been around for a few years. You know, the part that I'm focused on, and we'll talk a little bit about, is on some of the bio-based asphalt technologies. This I'm based out of our asphalt laboratory in Minneapolis, and that's where I'm speaking to you from today. Before we get too far, I also, you know, we have the pleasure of working with an esteemed partner in China, the Xiyufa Group, and my dear partner from this company, Mr. Xi Jianxin, is also online, and I'd like to ask him to maybe introduce himself if possible, and the company if possible.
Hi. Hello. Can you hear me?
Hello. Yes, we hear
Hi,
you.
Hassan. Really nice to meet you again.
Absolutely.
Yeah,
Nice
hello,
to meet
Mr.
Yes.
you.
Shu. Yeah, good to. Yeah, thank you.
Hello, Professor. Sorry, I'm at the airport. It's a little bit crowded, and but yes, Hassan sent me the invitation earlier, and I think it's a very good opportunity, and I'm honored to be here also today to introduce a little bit of ourselves. We are a Xiyufa Group, and we are based in Shanxi, Taiyuan, but we also have business nationwide. We have started this cooperation together with Cargill, I think starting from 2018, and mainly regarding to the rejuvenator business, but also we have other additives from the bio-based in our products also. And for us, we are not only material oriented, but also we have a contracting department. So we have a lot of maintenance. So we're based in Taiwan, and we also have a very good relationship with some universities. With your universities, your university unfortunately still not get any connection yet, but I hope today will be a very good start. And we are based in China, of course. So if in the first future, anything related to the rejuvenator or samples or testing this kind of thing, we're more than happy to help. And hopefully we can start some cooperation within these key parties. Okay, thank you very much.
Thank you, Xi, and I apologize for the slide kept on moving on itself here, so a little bit of a technical issue.
But it's in Chinese, so I think most people will understand. So
perfect.
Thank you
very much.
Yes.
Safe travels.
Okay, yeah, I will get security now.
Excellent.
Okay.
Thank you very much. Yeah, so the agenda for the speech today, I've organized this over 4 different topics. First, just kind of an overview of the state of sustainable practices in our industry. Then I'll follow this up with an introduction to bio-based materials and asphalt. After that, we'll specifically focus a little bit more on the recycling agent part of this, and as one of the most promising angles of achieving a low carbon future in our industry. And I think the very important part for us to end with is implementation examples and real world examples of how this is being used. So starting with the first part, you know, our industry I believe is very, is full of potential. And there's so many technologies that are being invented by researchers like yourself on the call. There's definitely a need and a passion in the industry to go for safer environments. It is an innovative industry, and people are looking for optimizing performance, lowering costs. And sometimes this is a slow thing. In many countries it's the same way. There's regulations and specifications, and just it takes time to implement change. And sometimes funding is a big part of it. So there's certainly challenges that this industry works with while trying to balance and go towards these goals. And every once in a while, some of these technologies you can go towards without having to sacrifice cost or performance. And I think that definitely the pavement industry has a number of these opportunities. So these are some numbers that, and they haven't changed too much in the last couple of years, but it's showing some of the potential. And this is numbers for the United States, showing that there's about 95 million tons of reclaimed asphalt pavement that's being milled off of roads. And 95% of this is recyclable, that can be recycled. The same thing with shingle asphalt, which is a lot of the roofing material in the U.S. made of this, is made of this. Significant amounts of this exist and can be recycled, and this would be equivalent to replacing about 26 million barrels of virgin asphalt. Now, this number of 95% is very promising, very impressive. However, we look at different statistics and we see a different picture. In the US, between 2018 and 2021, although RAP use went up to an extent, really that it has stayed as a percentage of total volume of asphalt very consistent. About 21-22% of asphalt uses recycled material, which is a very low percentage when we look at the opportunities that we see in a number of countries with the percent of recycling that's possible. So although 95% is recyclable, very little of it is actually being recycled by average. When we look at the carbon footprint of asphalt, looking at an environmental product declaration, and these are starting to become more common in a number of places to try and have these report cards that show the carbon footprint and emission potential, we can see that a significant portion of the asphalt mix carbon footprint is coming from either the asphalt binder or a lot less the aggregate, but a huge amount of it is coming from the asphalt binder, probably the biggest portion of this. This is followed by the energy that is spent on operating a plant and heating the aggregates and drying aggregates. So energy for heating and the asphalt binder production are the two biggest contributors to the carbon footprint of asphalt. And so when we look at reducing carbon footprint, those two aspects are definitely some of the ones to focus on significantly. So that's where the bio-based technologies come in and have started to be used. First off, what do we mean about bio-based? This definition can be pretty broad and mean a number of things. I would say at the broadest level, it can be referred to material that are derived from vegetable or agricultural sources, tree-based sources like tall oil, different carbohydrates like starches, sugars, proteins and derivatives, could be byproducts from different types of processes such as fatty distillates, recovered oils, waste products that come out of different refining processes. And it could be pyrolysis process from other byproducts such as cellulosic byproducts like lignin, husks, nutshells, animal sources. So you can see a lot of very different material could fall under the characteristic or the characterization as bio-based. In the asphalt industry, quite often bio-based has been used to describe bio-oils, although there's a lot of different types of products that have been referred to as bio-oils. One important thing to say to have in mind is being bio-based. Really, when you take into account how broad those source material can be, doesn't actually imply any specific type of performance in itself. Sometimes we see papers that say, biomaterials are, very good in terms of performance, or they are very bad in terms of, some aspect, let's say aging. And these are always a little bit misleading because you really have to say specifically what you are talking about, because you have every different type of performance, especially when you take into account that many of these materials can be chemically modified or engineered to have different properties. So saying something is vegetable oil based doesn't necessarily mean the same thing depending on how these are chemically modified. So for that reason, classifying biomaterial only based on the raw material source is also quite misleading. So more information is always needed to really characterize or categorize performance in biomaterials. So how are these used in asphalt? One of the perhaps methods that has been used the longest, although perhaps not as commonly known, is using bio-based modifiers to modify asphalt binder or bitumen. Quite often, these are very efficient replacements for using, say, aromatic distillates or other types of petroleum-based oils that are used to soften asphalt. Here you have an example showing for performance grade modification for a PEN 6422 to PEN 5828. Only 2 to 3% by weight can take a full grade change. And for those of you familiar with the performance grading system, one grade shift of 6 degrees means cutting the viscosity about in half. So it's almost halving the viscosity there. When you look at the penetration, you can kind of see the same type of range where, going to 0 to 10% of a bioadditive can have, much more of an impact on penetration than a flux oil might have. And for this reason, these have become quite popular in a lot of places for modification of asphalt binders and creating softer bitumen grades. Another category, which much more recently bio-based chemistry has become common in, is the warm mix or low temperature asphalt category. In this category, commonly in the past, organic additives have been used. Now, the term organic does sound like bio-based. However, that's not necessarily, that doesn't mean the same thing. Fischer-Tropsch wax, some of the stuff that comes out from coal processing, has been used often as a way to plasticize asphalt by creating a melting point near the processing temperature that allows for better processing, lower temperature processing as a plasticizer. And however, their use is not as common in the North America and Europe. And what has become more common has been use of chemical warm mix additives that are surfactant type modifier products that are able to work without modifying the grade of an asphalt binder by, and I'll talk in the next slide a little bit more about how these work. And although these have commonly been amine-based chemistries, more recently, there's more bio-based versions of these that are coming into the market. So when we talk about chemical warm mix additives, these are additives that are believed to perform by modifying the internal friction in a bitumen film, which allows for the better movement of aggregates and workability and compactability. They also, as a byproduct of that impact, often work as wetting agents. They modify the surface energy and surface tension of an asphalt binder and the bond characteristics on the interface between bitumen and aggregate, and can help as adhesion promoters. Um, as I said, as something that's a makes these more attractive than a wax is the fact that they do not change the grade of the bitumen. As you can see, you can achieve significant drops in production temperature, and sometimes much could be lower than the temperatures even seen in this example with the use of such additives. An example here is showing how an use of a bio-based warm mix additive is not changing the rheological properties of the bitumen. You can see softening point, penetration, even viscosity is not changing much. It might even in some cases look slightly higher, but statistically not changing. However, when you look at compaction, and here's an example of two mixes, one with a warm mix additive, a chemical bio-based warm mix additive, and one without. As expected with the normal asphalt, as you drop the production temperature, the air voids achieved at a fixed compaction effort continue to increase. However, when you use a chemical warm mix additive, like you can see in this example, although you do still see an increase in air void as you drop the temperature, you can see that that increase is a lot less. And you can see in certain points, there's a significant shift in the compactability temperature. You're achieving similar air voids with the warm mix at 20 to 30 degrees lower temperatures than you would with the hot mix alternative. And that means lower fuel use and lower carbon footprint. As we're talking about carbon footprint, here's an example showing how different amounts of temperature reduction will affect, for an example of a warm mix asphalt here, will reduce the carbon footprint. The reduction is in the A3 category, which is plant operation. That's where the fuel use is. And you can see that reduction of 25, 33, up to 45 degrees centigrade. We can get up to 25% reduction in the plant operation carbon footprint, which adds up significantly when you go look over a total production of an asphalt plant over a year. And looking at that, it's estimated that in the U.S. alone, if a 40-degree Fahrenheit reduction in temperature was implemented using warm mix additive, about 0.2 million tons of GHG would be reduced, which is equivalent of taking 46,000 cars off of the road, or using less than reducing about 1,000 rail cars of coal. These can start making a difference. Now, the last category that I'll focus on more is the recycling agents. And this is where bio-based technology is becoming probably the more popular version of it that's being used in some markets, especially in North America and Western Europe. So rejuvenators or recycling agents aren't a very new concept. They've been used for a while. They've been used because, as you know, asphalt ages and becomes brittle. And to use more of that recycled pavement, you need to soften it. Now, back in the 1970s and 1980s, the use of petroleum-based recycling agents, which were mostly based on lube oils, paraffinic byproducts, started to become popular. And these were used quite often, especially around the 70s. Oil prices started to go up significantly, and recycling became a lot more attractive. However, I would say in the late 2000s, with the recycling oil had another resurgence with the price increase of asphalt at that point. However, we started to see a lot more bio-based recycling agents coming into the market. Recycling agents are have advantages for use in recycling over using a soft bitumen. Part of it is because there's only a certain amount of bitumen softening you can do before you destabilize the mix, and it becomes a lot harder to balance the rutting and cracking performance at higher wrap contents when doing this. For those of you interested in getting a deeper history and overview on how recycling agents are used, I would definitely suggest looking up the NAPA, which is the National Asphalt Pavement Association in the US, QIP 131 report, which is downloadable from their website online, which is a practical guide to using recycling agents. So the information that I'm presenting today is also discussed in more detail in this report. So a recycling agent overall is going to be improving cracking resistance. That's a main goal there. It might decrease the high temperature stiffness and have some softening. Generally, it's not going to impact moisture resistance. It might improve compactability, as we'll see. And of course, you're looking to increase the recycling content. You may not need to increase the asphalt binder content as much as sometimes people do when they're using recycled asphalt. And it also can help eliminate what is sometimes called a grade dump, which in other words means using a softer grade than usual in an asphalt mix because you're using recycled material. So rejuvenation as a term is popular. It's a little inaccurate because it seems to imply that they are undoing oxidation. Rejuvenators are not chemically undoing oxidation. What they're doing is they are undoing, by a physical, chemical, more polar interaction, the impact of aging and oxidation on the performance, the brittleness, stiffness, and durability of an asphalt pavement. What that would mean is ideally is restoring the cracking resistance by overcoming that embrittlement that occurs in aged asphalt as it gels through the association of the more polar, heavier molecules, the asphaltenes, as they build up and become more more prone to association in an aged asphalt. However, it helps maintain rutting performance by being effective at lower dosages. It improves workability, compaction, and appearance. And this is important. A good rejuvenator is going to improve aging susceptibility of the pavement without, so that it has equal or better performance than a normal asphalt would. And finally, it will provide predictable and reliable result. You need to be able to know how it's going to impact your mix to be able to use it as a tool. Using recycled material sometimes adds a little bit of uncertainty. So the rejuvenator needs to be a predictable part of design component. You got all of that, you got a good rejuvenation performance. There is a video I can share the link to the folks interested in animation on online on YouTube that describes this, the actual physical chemical phenomena of rejuvenation in more detail for those interested, that I'll be happy to share the link in the chat. Recycling agents are classified in a number of different ways. Early classification systems have been by raw material source, which, as I mentioned, is not the best way to do this, especially when there's chemical or physical modification of some of these materials. So the best specification system is going to be based on the chemical and physical properties of the additives themselves. There's a number of different ways that these are being looked at, but one of the ones that is most commonly looked at today is the ASTM D4552. This standard is probably is a simple two-page standard. It has a table that probably some of you will find very familiar. And this essentially describes recycling agents as a function of their viscosity, and has basic requirements for flash point, amount of saturates, and the aging resistance of the material. In 2020, a RA0 category was added, this lowest viscosity one, to this table to better describe bio-based additives. So generally from the 80s, the table has had everything from RA1, which means from a viscosity of 50 or higher. However, this was found to not be suitable for bio-based additives, which today are actually the most common additive used as a recycling agent in North America and in Western Europe. So this category RA0 was added with lower viscosity without changing the other criteria of RA1. Simply, it was an expansion of the table that now makes it apply to both bio and petroleum-based additives. And most petroleum-based additives that are being used in that bitumen are probably in the RA1, RA5, which is a slightly higher viscosity. You can see here an example of a bio-based rejuvenator with a viscosity of 30 at 60 C will fall squarely in the middle of this RA0 category and can easily meet this criteria. There's a pretty similar table, as you can see here. This table from the specification of the highway asphalt pavement recycling requirements in China has similar requirements to the ASTM table. However, it does not have the 2020 update that occurred at the ASTM table, which would be that addition of the RA0 category for the lower viscosity, which would allow the use of those bio-based additives with this specification without changing any of the physical chemical requirements that are here. So how are warm mix or rejuvenator additives used? So they can, depending on how the additives are, what type of plant we're using, both recycling agents and warm mix additives can be added in a drum plant or a batch plant, be added into the virgin bitumen. This is a very common way for adding these. This is usually used with an additive pump and it is injected into the virgin bitumen. At a drum plant, that would be into the pipeline going into the drum for a continuous plant. And in a batch plant, that would be going into the balance of the bitumen with an additive pump. As the bitumen is filling into the balance, the additive is added in there. With a batch plant, there's a few other ways that rejuvenators are being added. A lot of folks in Europe do this. They spray it on the wrap itself on the spray bars. This might be before or after going through a wrap dryer. Some people actually spray it in the pug mill at the very end and mix with the blend. However, for warm mix additive, you can only add it to the virgin bitumen. So that will always need to be injected into the balance. As I mentioned, a lot of time, one of the first things that you will see with the recycling agent is a reduction in improvement in workability and compaction with higher wrap. As you can see very clearly here, that with a reduction of temperature, you're not only maintaining compactability, but you're improving it, which is significant when you're going from 30% to 50% wrap. For implementation, for time, I'm not going to go into too much detail, but generally there's a few steps that are happening. You look at the basic requirements using something like the ASTM table or the table that in the Chinese standard. And look at determining the dosage based on the bitumen properties. That might be with penetration, could be softening point, we could be with low temperature performance grade. Often the additive supplier is a big part of this conversation here. After that, it's determining the design is confirmed using a performance-based design. Usually that is a normal design with some performance testing checks using locally accepted performance tests. And quality management is generally not going to change very much from what's normally done. There may be a higher frequency of wrap burn tests where you do the gradation and binder determination. Generally, for local or private pavements in North America, the first two steps are the only one that are really done. and a dosage is established, and it is, after that is basic quality management. Not a lot of mix design, the mix at the mix level, you're not doing performance testing. However, sometimes for when using with agencies for public mixes, the agency will require those additional mix testing in order to qualify that final mix. The dosage determination is going to be done generally by classification of the recycled asphalt binder with extraction recovery, looking at either penetration, low temperature properties, or various rheological aspects. And then using that, you can determine how much dosage of additive is needed to get, say, a standard mix that maybe only has 10% wrap to get to like 15, 20, 30, 40% wrap while maintaining the same properties. That can all be calculated by determining the properties of the basic asphalt binder and the wrap that would be used in it. Some changes sometimes are made on the mix design process when you're using a recycling agent with high wrap. The volumetric part might not change too much. There may be some performance tests like an indirect tensile strength or a wheel tracking test that might get added. However, a specification will require a loosening up on the maximum wrap content allowed. If a specification has a dust to binder ratio, that is a ratio of the passing number 200 mesh, the 75 micron mesh, to the binder content, that requirement might need to be modified because usually recycled wrap will have more dust on it, so it'll be hard to meet these. And that also means the average film thickness of bitumen on the aggregate might decrease. So if a specification has film thickness requirements, those will need to be modified. Sometimes for wrap, higher wrap content, maybe above 50% wrap, you will require a fractionation of the wrap into coarse and fine wrap to be able to control your gradation. Often at less than 40% wrap, fractionation is not commonly done. So here's some implementation examples that I will go through quickly as I see I'm getting towards the end of my time. The National Center for Asphalt Technology, this was a very important test done at this is a world famous test track in Auburn, Alabama, where trucks like this are driving every day on 3-year cycles over these pavements to load them. And they put 10 million easels, equivalent single axle loads, over a 3-year period. In this case, a mix with warm mix additive and a mix with recycling agent and high wrap were put down. And these have been, at this point, subjected to 20 million equivalent single axle loads, which is more than most highways in the US. And what has been seen is ride quality has remained quite good. The roughness has not changed, especially in the high recycled mix, as you can see here. There was a utility cut before the warm mix section that affected the roughness measure. However, as you can see, 0 cracks in both sections throughout this pavement testing throughout 10. This is from the first 10 years, first 3 years, 10 million cycles, and I can tell you at this point, after nearing 20 million, there is still no cracking, and there was no significant rutting either, less than 5 millimeters of rutting. So very significant loading and nearly no distress or damage after more traffic than most pavement highways would take in the US. Another example was done at a much cooler region. This is close to where our lab is in Minnesota. And again, this was designed for low temperature cracking resistance, 45% wrap. So performance testing were showing that performance were equivalent or better. However, the important thing is after 5 million easels of this is real traffic that's going on. This is a 4-lane highway, a 3-lane highway on either side. And 6 winters, including one of the record coldest winters in Minnesota, which is one of the coldest states in the US, there has still been no need for maintenance on this road, which generally has to happen because there's a lot of transverse cracks that open up very widely. So definitely, there's no need to sacrifice pavement performance as shown in these two test sections with at high RAP content. Here's an example of 70% RAP in Netherlands. Netherlands have been using recycling agents and rejuvenators for 70 to 85% RAP for years now, and they have performance testing using the their beam fatigue testing and a dynamic rutting test. And you can see here that actually using a paving grade asphalt with the rejuvenator, you have a better ability to balance performance, cracking resistance against rutting than you do if you use a very soft bitumen like a Pen 160-220 for the same mixes where you are unable to meet cracking without failing the rutting performance. This is very normal performance. I would say at this point, maybe 70% of the asphalt plants in Netherlands are using this type of technology. So very common to use this very high RAP content with rejuvenation. Here's an example of runway. This is the Amsterdam Airport or Schiphol, very major airport in the world for international flights. And this was done, again, 60% recycled. Normally, there's 0% recycled, and they're doing 60% recycled now on their runways using rejuvenator. So these don't need to just be used in low severity mixes or low service level mixes. These are being used in pretty high impact, high service pavements as well. And last but not least, this has been tried out, and a couple of examples in China as well. And I don't know if Mr. Xi, I see you're on. I don't know if you are in a place that you can speak to these or not, but if you are, do you want to briefly describe these trials? Oh, perfect.
Yes. I just got off the train, so just in time. Yes, starting from 2019, we have started to use ANNOVA rejuvenator in our asphalt mill. We have two asphalt mills here in Shanxi with recycling ability. One is with Aman from Switzerland, and the other one is a Chinese mill. And we are also using this on the top layer recycling and use that into the top layer, because this is what we are trying to do with this the upcycling instead of the downcycling like we always do, to just use in the base or middle layer. The performance for now are all very good. And also starting from last year, we started to cooperate with Rio in Beijing, and they have this in situ hot recycling for porous asphalt in Zhejiang province. This is also the first time in China that we ever done this hot recycling for porous asphalt, also the surface layer, top layer. The reason they chose our rejuvenator is also because it's a combination of recycling but also warm mix. Because in the past they actually need to use two components, one rejuvenator and one warm mix additive. And after testing our sample, they were sure that by just using our own single component ANNOVA rejuvenator, they can achieve both rejuvenation and also warm mix property. So that's also a very good indication for the property of ANNOVA and the bio-based rejuvenation technology. So yes, that's the development here in China so far. And thank you, Hassan.
Thank you very much for that. Yeah, and so in conclusion, there's I would say millions of tons of asphalt are being put down right now around the world using these rejuvenating technologies for high performant mixes. There's multiple ways for getting low carbon asphalt, as we talked about. It's increasing RAP content is one of them. Replacing fossil-based bitumen with bio-based material, of course, is offsetting some of that, and reducing production temperatures. Some of these are not experimental anymore. These are very much real-world technologies that are being used quite commonly now. The NCAT and MnROAD studies that I showed have been used as a reference for a lot of agencies that are looking to implement these technologies. because of their third-party, independent, reputable sources for field data. And looking at that experience and what was presented here, the summary, that 4-step process of using a criteria for classifying and certifying recycling agents, then initial dosage based on wrap and binder properties from extraction, and finally, verification of design using performance testing or standard quality testing is a very practical process with small modification to be able to use these recycling agents and recycled content. Of course, quality management is always going to be important. And you can see here, high wrap and rejuvenation. There's significant impact with just going 20% higher recycled content, as you can see, the millions of tons of GHG reduction. With that, some of the references I've used and some of the stuff that I mentioned, and I would like to thank you all, and thank Mr. Shi Jianjin as well for the support in this presentation today, and definitely happy to try to answer any questions you might have.
Well, thank you so much, Hassan. Thank you so much for your presentation. It was really, to me, very insightful and really very interesting, very informative presentation to really introduce this type of bio-based asphalt additives toward the decarbonization of asphalt industry, which is something that getting momentum over past several years. And I think what you've done and what you're doing in your company is really meaningful. It's something that, of course, has a great great contribution towards the making our roads more sustainable. In fact, thank you so much. Okay, so we can just directly go and ask our audience if they have any question. Okay, so we have Professor Saleh from University of Canterbury. Professor Saleh, please turn on your mic, and thank you for joining us.
Thank you, Alex. Thank you, Hassan. This very nice presentation. Sorry I missed the first part because I was in a meeting, but I would like to ask you, I'm not sure, maybe you talked about it before I did join. Do you have any performance data for bio-based binder, like long-term performance for bio-based? And if you do, what exactly was it, 100% bio-based, or it is mixed with other petroleum-based bitumen?
Excellent. Thank you, Professor, for the great question. It actually brings up a good topic, one that I didn't really focus on. So the topic of biobinder. And it is definitely, I would say, one of the emerging topics that are being focused on. I did not talk much about it because I was focusing more on things that are commercial today in our industry. Definitely biobinder on the research side is one of those that a number of folks in the industry are working on creating some of that long-term data on it. I know that there's some examples in France that they have gone with 100% bio. We've worked on and have performance data on cases where you go with high wrap, close to 100% wrap, with bio-based additives kind of making up the difference with good performance. But I would say most common, what I expect us to see in the very near future, and there's some examples becoming commercial this year and the next couple of years, is going to be partial offset of the petroleum-based binder with biomaterial. This will probably, I would say, the bio binders right now that are coming on the market generally have something about 10 to 15% bio content on them. And they're looking more to use biogenic carbon footprint calculations to offset a higher percentage of the carbon footprint than their actual weight percentage is. I don't expect us to see commercial or a lot of very big field performance and performance data on 100% bio in the very near future. Plus the fact that the scale of biomaterial available makes it very difficult for that to be a very reasonable alternative.
Thank you so much.
You.
Yeah, one more thing, if you allow me. Do we have any studies about the energy demand to create the biobinder? Because the basic thing is to offset the carbon footprint. But if the energy demand is high, then this will defeat the purpose.
Correct. Yes, and I think that that's going to be a requirement for every biobinder that becomes commercial. One of the things I talked about towards the beginning of my presentation was the EPDs, the Environmental Product Declaration, and markets like the Nordics, like Netherlands and Sweden, UK, and other places that are looking at biomaterial. This will require it to come with a EPD based on a life cycle assessment that shows the carbon footprint, that will include the energy used for manufacturing. And in Europe, this will also include the biogenic carbon, the carbon that's sequestered in biomaterial in the calculations as well. In North America, it won't, but to your point, carbon calculations will definitely be part of any bio-based integration. And that's what we're seeing in some of these markets that are starting to do it.
Thank you. That's very nice. Thanks so much.
Thank you very much.
Okay. Thank you. Thank you, Hassan. Thank you, Professor Saleh, for your question and also for your answer, Hassan. Okay, the Haibo. So I think, yes, you can ask your question. Thank you.
Okay, thank you, Hassan. A very interesting topic. And I have one very simple question. Like, is it possible for us to get some samples of because when we want to use some products in like Southwest China, maybe the environment is different, like Shanxi province. So we want to see like this bio asphalt can be used in our environment. So we want to do some like deeper analysis. So is it possible to get some like Cargill sample?
That's absolutely one of the reasons why I, included our partner, Mr. Xi Jinping, and on this call. I think they will be the people, and I'll in the copy of these slides, and I can, I'll be happy to put that in the chat as well for folks interested to reach out to him and to Xiufa. And they will be, as our representatives, they'll be able to provide these samples and work with you.
Okay, thank you very much. Because we are interested in it. We are not interested for the how to make it, but we are interested in the performance. Like if these additives can be used in our like Southwest China, like this environment is a little different. Yeah,
absolutely. That's the first step to implementation.
Okay.
Makes sense.
Okay,
Yes.
thank you.
Okay, great. Thank you, Haibo.
So we have the Dr. Xu.
Yes.
So we have
yes, and
like
Professor Raham also have my email. So later he can send me the address so that we can prepare some samples for you. We also have a newly established company in Chengdu last year, starting from last year. So we have some local contact there also.
Okay, thank you. 谢谢徐总，谢谢。
Yeah, 没事。
Great. Thank you, Mr. Xu. Thank you, Hassan. Okay, any other question among audience? Please raise your hand, or although we are running a bit out of time, and okay, so okay. Yes. Okay. Yes. We have. Yes. Oh, I made mistake. Raise my hand. So it seems no more questions from audience. Thank you again so much, Hassan, really appreciate again for accepting my invitation. Thanks for your time, and thanks for your again very interesting and current presentation and speech. And we are really looking forward to further expand our collaboration, whether with you there directly, it or with your representative in China, for future. And hope maybe in future we can have you in Chengdu. We warmly welcome you also to visit our university, and you're warmly welcome. And we are looking forward to that.
Thank you very much. Thanks for having me, and it certainly will be wonderful to see you and visit in person. And definitely, it was a privilege talking to you guys and presenting today. So thank you very much.
Yeah, thank you so much again, Hassan. Thank you
Thank
everyone for attending this webinar. Thanks for your time, and please stay tuned for our upcoming webinar. And wish you everyone have a nice day, night. Thank you, everyone. Bye bye.
Thank
Thank you. Bye.
Thank you, Hassan. Bye. Thank you, everyone. Bye.